Lesson 22.2, Shape, Center, and Spread. Which measures of center and spread are appropriate for a normal distribution and which are appropriate for a skewed distribution? For a normal distribution, you can use the mean and standard deviation. Use the mean and standard deviation. Or the median and IQR, the interquartile range, IQR. For a skewed distribution, you're going to want to use the median and the IQR. Exploring 1, seeing the shape of a distribution. Raw data values are simply presented in an unorganized list. Organizing the data values by using the frequency with which the results occur in a distribution of the data. A distribution may be presented as a frequency table or as a data display. Data displays for numerical data such as line plots, histograms, box plots involve a number line, while data displays for categorical data such as bar graphs and circle graphs do not. Data displays reveal the shape of a distribution. The table gives data about a random sample of 20 babies born at a hospital. Okay, now if you go to your calculator, you can see I've already put it all in, but to put it in, you would go press the on button and then go to spreadsheets, and then up here you put a label and then you fill it all in. I went ahead and did that already. Let's see, my documents. I put it in here. Let's see here. New document. Nope. And so then we can hit my document and we'll go back to where we were. So like I said, I've already put it in there for you. So make it go a little faster. Make a line plot for the distribution of birth months. Now, to do that in a calculator, let's go back here. Birth month, that would be this column here, and we'll click on, and then see the bar graph here, we'll click on that, and then we'll put birth month. All right, and there you go. That's what it looks like. And we'll do it over here on this, nice and pretty. And let's see what we got. We got 2 in July, 1 in August, 2 in September, 2 in October, 2 in November, and 1 December, baby. All right, so that's a line plot for the distribution of birth months of the babies. Make a line plot for the distribution of birth weights. Now, these weights are in kilograms, and a kilogram is about 2.2 pounds. And we can do it in our calculator. We'll just get us a new page here. And we're doing birth weights. B weight. And then there it goes. So that's what that looks like. And to do it on here, let's see. To do it on here, 3.2, there was 1. 3.3, there was 2. 3.4, there was 4. And 3.5, it looks like there were 6. 1, 2, 3, 4, 5, 6. 4 3.6s. And 2 3.7s. 1 3.8. Make a line plot for the distribution of mothers' ages. All right. There was 22 that were 28 years old, 4 that are 29, 4 that were 30, 3 31s, 2 32s, 2 33s, 1 34, 1 35. I think there was 1 39. All right. Good. Describe the shape of the distribution of birth months. Birth months. Let's see. Birth months. Let's take a look at it. It looks like the distribution is fairly level. That means that the data are more or less evenly distributed. So the distribution is fairly level. Number 2, describe the shape of the distribution of the birth weights. So here's the birth weights. It's kind of got a mound shape to it, right? And it looks fairly symmetric. You got the tail over here, and it's got 1, 1, and that's got 2, 2. Yeah, mound shaped and symmetric. The distribution is mound shaped and symmetric. Describe the shape and the distribution of the mother's ages. And, okay, so let's see. This one here was kind of like, it looked kind of mound shaped. And look at this in here. This is also mound shaped. But the right tail, it has a lot more of a right tail than the left tail. So you might say that one is asymmetric. Uh, the See how this in here, both tails, let's see here, both tails, that would be symmetric. This is more uh, asymmetric. So the distribution is mounded. Mounded and asymmetric. That is the tail trails off. More to the right than the left. Good. Relating measures of center and spread to the shape of a distribution. As you saw in the previous Explorer, data distributions can have various shapes. Some of these shapes are given names and statistics. A distribution whose shape is basically level, that is, it looks like a rectangle, is called a uniform distribution. A distribution that is mounted in the middle with symmetric tails at each end, that is, it looks like a bell shape, is called a normal distribution. A distribution that is mounded but not symmetric because one tail is much longer than the other is called a skewed distribution. When the longer tail is on the left, the distribution is said to be skewed left. When the longer tail is on the right, the distribution is said to be skewed right. The figures show the general shapes of normal and skewed distributions. All right. Shape is one way of characterizing a data distribution. Another way is identifying the distribution's center and spread. You should already be familiar with the following measures of center and spread. The mean of n data values is the sum of the data values divided by n. If x sub 1, x sub 2, and so on to x sub n are data values from a sample, then the mean x bar is given by x bar equals the average of those numbers. The median of n data values written in ascending order is a middle value. The median of n data values written in ascending order is the middle value if n is odd and is the mean of the two middle values if n is even. The standard deviation of n data values is the square root of the mean of the squared deviations from the distribution's mean. If x sub 1, x sub 2, and so on to x sub n are data values from a sample, then the standard deviation S is given by S equals the square root of, in parentheses, x sub 1 minus x bar squared plus x sub 2 minus x bar squared plus, and so on to x sub n minus x bar squared, all divided by n. The interquartile range, or IQR, of data values written in ascending order is the difference between the median of the upper half of the data, called the third quartile, or Q3, and the median of the lower half of the data, called the first quartile, or Q sub 1. So IQR equals Q sub 3 minus Q sub 1. To distinguish a population mean from sample mean, statisticians use the Greek letter mu, written mu, instead of x bar. Similarly, they use the Greek letter sigma, written sigma, instead of s to distinguish a population standard deviation from a sample standard deviation. Using a graphing calculator to compute the measures of center and the measures of spread for the distribution of baby weights and the distribution of mother ages from the previous explorer, begin by entering the two sets of data into 2less on a graphing calculator. So we're going to do baby weights and mother's ages. Okay, baby weights and mother's ages. Calculate the one variable statistic for the distribution of baby weights. Okay, baby weights. And let me show you how to do that in the calculator. All right, so here we go. Let's go back here to this. And we're going to do baby weights. We're going to do B here. All right, so the way we do that, press menu, 4, 1, 1 variable statistic, number of lists, 1, and we're going to do baby weight, and let's see here. It says result in first. I don't want to put it there. I want to put it in, let's see here. Let's put it in G, because I don't want to mess up my other data. So we'll put it in G. Okay. All right, so G, there it goes. It's over here. So what are we looking for? We're looking for the X bar. So the X bar is 3.5. 3.5. What's the median? Okay, we'll have to scroll down here. There's the median, 3.5. And S, let's go back up here. S is 0.148, so we'll just say 0.15. And the IQR is Q3 minus Q1. So let's go back down here. Q3 is 3.6 minus 3.4. So that's going to be 3.6 minus 3.4, which is 0.2. Now let's calculate the one variable statistic for mother's ages. Let's go back here, and then we'll menu 4, 1, 1, number list 1, okay. And let's see here, let's find mother's age, MH, right? We're doing the mother's age. Okay, and see, it's just going to write it right over the, yep, we're just going to write it right over the top of that. Okay. So what was the X bar? 31.15. 31.15. The median is going to, remember this one was kind of skewed a little bit. So the median is going to be 30.5. 30.5. 2.5. The S is 2.68, so we'll just say about 2.7. And the IQR, that's Q3 minus Q1, that's 32.5 minus 29, 32.5, 32.5 minus 29, and that's 3.5. All right, not too bad, not too bad. So let's see, reflect. What do you notice about the mean and median for the symmetric distributions baby weights as compared to the mean and median for the skewed distribution, the mother's ages? Explain why this happens. Okay, let's see. Tired of red. The mean and median for a symmetric distribution are equal or almost equal. But the mean and median for a skewed distribution are not. This happens because the mean is pulled toward the data values in the longer tail, but the median is not. Okay, so let's see here. The mean, and I'm going to say X bar, and median for a normal distribution are equal. But the mean and median for a skewed distribution are not. This happens because the mean is pulled toward the data values. In the longer tail. But the median is not. All right, and let's go back and look at that. All right, see this 39? That pulls the mean to the right, which makes the mean larger. But it doesn't do that with the median because the median is the middle number. The standard deviation and IQR for skewed distributions are significantly greater than the corresponding statistics for symmetric distributions. Explain why this makes sense. The data are more spread out. The data are more spread out. In the skewed distribution. So the measures of spread are or should be greater. And let's go back and look at our example again. See this 39? It pulls that mean. It also makes the spread that's a lot wider than the spread of this data here. Okay. Which measures of center and spread would you report for symmetric distributions or normal distributions? For the skewed distribution, which measures and spread would you report for the skewed distribution? Explain your reasoning. Okay. Let's see. Report either the mean, well, let's use that Greek symbol, the mean and standard deviation, or the median and IQR for the symmetric distribution. But only the median and IQR for the skewed distribution. Because the mean and standard deviation are too sensitive to the data values. And the long tail. All right, great. Making and analyzing a histogram. You can use a graphing calculator to create a histogram of numerical data using the viewing window settings xmin, the least x value, and xmax, the greatest x value, and x scale, the width of an interval on the x-axis, which becomes the width of the histogram. Using a graphing calculator to make a histogram of the given data and then analyze the graph. Okay, so let's see, make a histogram of the baby weights. So we're going to do the baby weights. All right, let's go over here and let's click on that. Let's get us a new window. Baby weights. Baby weights. All right, so there we go. Well, I'll say that's a line plot. We wanted a histogram. So let's look. Let's see, menu, plot type, menu 1, and then histogram 3. There we go. Now we have a histogram. Cool. All right, so we'll skip all of that right there. Okay. By examining the histogram, determine the percent of the data that are within one standard deviation, S is approximately 0.14, of the mean, X bar equals 3.5, That is, determine the percent of the data in the interval 3.5 minus 1.4 is less than x is less than 3.5 plus 1.4, or 3.36 is less than x is less than 3.64. Explain your reasoning. The bars for x values that satisfy 3.36, the interval from 3.36 to 3.64, have heights 4, 6, and 4. So 14 data values out of 20, or 70% of the data, are in the interval. Suppose one of the baby weights is chosen at random. By examining the histogram, determine the probability that the weight is more than one standard deviation above the mean. That is, determine the probability that the weight is in the interval x is greater than 3.5 plus 0.14, or x is greater than 3.4. Explain your reasoning. Okay, so the bars for x values that satisfy x is greater than 3.4 have heights of 2 and 1, so that the probability that the weight is in the interval is 3 over 20, or 15%. All right, now let's do one of these. We'll do all of it together. B. It says the table gives the length in inches of a random sample of 20 babies from Explorer 1. Okay, now I went ahead and put those in. So let's see, new document. Nope. And then my documents. And, ooh, all right. So baby length right there. I got it right there. Okay. Now, make histogram of the baby lengths based on the shape of the distribution. Identify what type of distribution it is. So let's take a look at it. Let's make a histogram. And let's baby length. Oh, that looks pretty symmetric, doesn't it? It said histogram. I'm making a histogram. There we go. There's our histogram. Now that looks real. That's mound shape, symmetric. All right. So the distribution has a central mound and symmetric tails. So it is a normal distribution. By examining the histogram, determine the percent of the data that are within two standard deviations. S is approximately 1.4 and the mean is 20. Explain your reasoning. Okay, so let's see here. Standard deviation is 1.4, the mean 2. So we're going to have 20 plus 2 times 1.4 and 20 minus 2 times 1.4. All right, so let's get 20 plus 2 times 1.4. That's 22.8. And minus, let's go up there. I hate when it does that. 17.2. So 17.2. The interval for the data that are within two standard deviations of the mean is 17.2 is less than x is less than 22.8. The bars for the x values that satisfy 17.2 and 20 is the interval 17.2 to 22.8 have heights of, well, let's go and look. 17.2 to 22.8. 17.2. So we're looking at 2, 4, 6, 4, 2. All right. So 2, 4, 6, 4, and 2. So let's see. At 10, 12, 16, 18 data values out of 20, or so 18 out of 20. 18 divide 20. I got 90%, 0.9. 90% of the data are in the interval. Suppose one of the baby links is chosen at random. By examining the histogram, determine the probability that the length is less than 2 standard deviations below the mean. Explain your reasoning. The interval for the data that are less than 2 standard deviations below the mean is x is less than, and that would be 17.2. The only bar for x values that satisfies x is less than 17.2 has a height of, I think it's just 1. 17.2. Yeah. 1. 1. So the probability that the length is in the interval is 1 over 20, or 0.05. Or we might say 5%. Good. We're moving right along here. Your turn. The table lists the test scores of a random sample of 22 students who are taking the same math class. Okay. I went ahead and did that already. Let's see. New document. No. On and my documents and test scores. There it is. I went ahead and put it in. So there's all the test scores. All right. Right off the table. Let's go back. What are we supposed to do? Using a graphing calculator, make a histogram of the math test scores. Based on the shape of the distribution, identify what type of distribution it is. So let's see here. We need to make, we need to make a histogram. So we'll go down here and we put test scores. That looks pretty good. And menu 4, 3, and now we have a histogram. And let's see here, 3 out here, 3 out there. That looks fairly symmetric. So the distribution has a central mound and symmetric tails. So it is a normal distribution. All right. By examining the histogram, determine the percent of data that are within 2 standard deviations of the mean and explain your reason. So let me show you how let's see here. Let's go back to our data and let's see. Menu 4, 1, 1. Number of lists, 1. We only got 1 there. Okay, and we want test scores, and we'll just put it right there in B. So X bar is 83, and the standard deviation is 6.4. 6 point, well, it's using 6.3 and 83. So that's how I got 83, and well, it's using the population 6.3. All right, so good. By examining, let's see, by examining the history and determine percent of data that are within 2 standard deviations. So we're going to have 83 plus 2 times 6.3, and then 83 minus 2 times 6.3. That'll give us our interval. So 83 plus 2 times 6.3. That's 95.6. And the lower end, 70.4. Okay. So our interval is 70.4 is less than X is less than 95.6. Determine that are within 2 standard deviations. So how many are inside of that? Let's go and look. And we're looking at from 70.4 to 95.6. 70.4. So we're going to start here at 1. We got, looks like we got 1, 1, we got 1, 1, 2, 3. 1, 1, 2, 3. 1, 1, 2, 3. That's 3. And it's and then that's 6, 3, 2. 6, 3, 2. 6, 3, 2. Right, that's 1, 1, 1, 1. And it's 1, 2, 4, 7, 13, 16, 17, 18, 19, 20. So we have 20 data values. Out of 22. So let's go to our calculator. 20 divide 22, control enter, and that's about 0.909. That's, we're going to say it's 91% or 91% of the data are in the interval. Suppose one of the math test scores is chosen at random. By examining the histogram, determine the probability that the test score is less than 2 standard deviations below the mean. So we're looking at something that, let's see, X is less than 70.4. And there's only one. There's only one. That one right there. Okay, so there's only one. So that would be 1 over 22, which is 1 divide 22. and 0.045. Yeah, we'll just say 0.045, which is approximately 5%. All right, that's not too hard. Making and analyzing a box plot. Now it's a party. A box plot, also known as a box and whisker plot, is based on 5 key numbers: the minimum data value, the first quartile of the data values, the median, the second quartile of the data values, the third quartile of the data values, and the maximum data value. A graphing calculator will automatically compute these values when drawing a box plot. A graphing calculator also gives you 2 options for drawing box plots, one that shows outliers and one that does not. For this lesson, choose the second option. Okay. Use a graphing calculator, make a box plot of the given data and analyze the graph. Make a box plot of the mother's ages from Explorer 1. How does this box plot show that that this skewed distribution is skewed right? Okay, and that's what it's going to look like. All right, now let's do that. Let's do that. And so let's click on new document. Test scores don't have that. So, and then we'll have to go back to the Explorer 1. There it is. And we were doing age, right? We're doing age. So that's going to be C. Menu. And let's put the age in there. Mother's age. And it looks like that. All right, we want a box plot. So menu, 4, 2, and there it goes. All right. See how it shows you the outlier of the 39 out there? Good. Now that's a little bit different than the other calculator. Let me see here. Menu, plot properties. Oh. Menu. Okay, extend box whiskers. All right, that makes it look like the other one. Okay. Suppose one of the mother's ages is chosen at random. B, based on the box plot and not the original set of data, what can you say is the approximate probability that an age falls between the median 30.5 and the third quartile 32.5? Explain your reasoning. The median 30.5 and 32.5. Okay, so let's look at it. This has 25% of the data. That has 25% of that. That has 25%, and that has 25% of the data. Okay, that's the way it works. So the probability is about 25% because Q1, the median, and Q3 divide the data into 4 almost equal parts. So B, the list gives the ages of a random sample of 16 people who visited a doctor's office one day. All right, we're going to make a box plot, and we're going to do this one here together. So let's go to our calculator. And let's see, new document. No. All right, we're going to go to lists and spreadsheets. And we're just going to call this age. All right. And let's put them in. 80, 52, 58, 64, 70, 80, 78, 35, 78, 74, 82, 73, 80, and 80. That's supposed to be 16, and that is 16. Let's get it back up in there. All right. So we want to make a box plot. So let's go and we'll hit, and we'll age, define it as age. And then we will menu 4, 2, and menu 2, 3. All right, and that makes it look like it. There we go. All right. Make a box plot of the ages. How does the box plot show that this skewed distribution is skewed left? The part of the box to the left of the median is slightly wider than the part to the right. And the whisker on the left is much longer than the one on the right. Okay. So if this line here was, or if this box here was about the same size as that box there, and if this long whisker here was the same as that whisker right there, then it would be a normal distribution. Okay. All right. Suppose one of the ages is chosen at random. Based on the box plot and not the original set of data, what can you say is the approximate probability that the age falls between the first quartile, 67, and the third quartile, 80? Explain your reasoning. The probability is about 50% or 0.5, because Q1, the median, and Q3 divide the data into 4 almost equal parts. So there are 2 parts that each represent about 25% of the data between the first and third quartiles. All right, so here we got number 8. The list gives the starting salaries in thousands of dollars of random sample of 18 positions at a large company. Use a graphing calculator to make a box plot and then analyze the graph. So here we've got these right here. So we want to make a box plot. Let's go to our calculator and let's see, new document, no, list and spreadsheet, and we'll call this salaries, SAL. All right, so we've got 40, 32, 27, 40, 34, 25, 37, 39, 40, 37, 28, 39, 35, 39. Oh, I put 399. 39, 40, 43, 30, 35. 18 salaries. That looks pretty good. We're trying to make a box plot. So let's see here. We're going to go to the bar graph thing, and we'll put salary right there, and then menu, box plot. All right, good, good. And I don't know if y'all know it, but you can like see 25. That tells you where it is. It automatically calculates that stuff for you. Isn't that pretty cool? All right. So what? Let's see. Make a box plot. We did it. How does a box plot show that this skewed distribution is skewed left? Okay. How does it show it's skewed left? This whisker here is a lot longer than that whisker there, right? Okay. And this box here is wider than that box there. So make a box plot of the starting. How does the box? Okay, the left whisker, the left whisker is longer than the right whisker. And the left box is wider than the right box. Okay. Suppose one of the starting salaries is chosen at random based on the box plot and not the original set of data. What can you say is the approximate probability that the salary is less than the third quartile, 40? So the third quartile, 40. It's less than this. Okay. Explain your reasoning. All right. Remember, this is 25% of the data. That's 25% of that. That's 75% of the data, or that's 25%. And so each one of these is 25%. So if it's going to be less than 40, that means it's going to be 75%. 75%. There's a 75% chance that it will be less than 40 or Q3. Okay. Good. Number 9, explain the difference between a normal distribution and a skewed distribution. Well, a normal distribution is mound-shaped with two symmetrical tails. The mean and median of a normal distribution are equal or almost equal. A skewed distribution is also mound-shaped, but one tail is noticeably longer than the other. The mean is usually greater than the median in a right-handed distribution and less than the median in a left skewed distribution. Okay. A normal distribution is mound shaped with two symmetrical tails. The mean and median of a normal distribution are equal or almost equal. A skewed distribution is also mound shaped, but one tail is noticeably longer than the other. I see. We'll say mean is greater than the median, in a right skewed distribution, and the mean is less than the median in a left skewed distribution. All right. Describe how you can use a line plot, a histogram, and a box plot of a set of data to answer questions about the percent of the data that fall within a specified interval. Okay. Uh, let's see. The three types of data displays organize numerical data using a number line. Okay. A line plot preserves the data values. And you can simply count the number of data values that fall within a specified interval. And you can simply count the number of data values that fall within a specified interval. A histogram uses the heights of the bar to indicate the number of the data values in intervals of equal width. In intervals of equal width you can sum the heights of the bars whose intervals are part of the specified intervals. All right. A box plot shows the points that divide the data. Let's see. A box plot shows the points that divide the data. The points that divide the data into 4 equal parts. So the specified interval must be expressed in terms of the dividing points. Or quartiles. Which means that the corresponding percentage of data will be a multiple of 25%. All right, good. Essential question check-in. Why are the mean and standard deviation not appropriate statistics to use with a skewed distribution? Because the mean and standard deviation are calculated using every data value. Data values that are much larger or much smaller than the other data values can have a significant impact on those statistics. So the mean and the standard deviation may be too sensitive to the data values in the longer tail of a skewed distribution. The mean and standard deviation may be too sensitive to the data values in the longer tail of a skewed distribution All right, folks, great lesson. Thank you very much, and I'll see you tomorrow in class.